Yeah. Welcome to Monday. We're doing 1.6 homework questions. So the only little correction we have is on the vocabulary check, the matching questions here. Notice you have an A, B, C, D, E, F, and then all of a sudden there's an extra E in there in the list. HI. So this guy should be a G, but then when you look at your answer book, there is also a G in the answer, right? In the answer. So it was just a typo there. So just put in G for that one. Okay. So any homework questions off of 1.6? Go. This is the library of functions. 37?
39 and 45.
39, 45. Absolutely.
Did we go over what we did in like problem 1 class?
Say that again.
So in problem 1,
Uh-huh.
you have like f parentheses 1 equals 4, and then f parentheses 0 equals 6. And you meant to use those as coordinates and put them into different formulas.
Gotcha. Okay.
Did we go over that in class?
Not specifically, but let's go over it now. As soon as you see it, you're like, oh yeah, that makes sense. So let's go for it here. So starting off number 1, it says write a linear function f. Now, whenever you say linear function in your mind, linear function, you should automatically think to yourself, oh, write a linear function, that means this. Right away. And if that's the case, then I'm trying to figure out, okay, what's the y, what's the f? So whenever we have a function, that guy and this guy corresponds to the 0.1 comma 4. This guy corresponds to 0 comma 6. Are we good? So hold on. Let's think back to the earlier part of chapter 1. This is number 1. And so these guys are just write a linear equation given 2 points. And I think what we have to do is we have to plug it into here. But we were missing our slope. So do you guys remember that one? That was actually on the... Yep. So y2 minus y1 over... So y2 minus y1, 0 minus 1. So 2 over -1 or -2.
Yeah.
There we go there. So then what we do is we just pick a point. Doesn't matter 1, 4 or 1 or 0, 6, because both these points are actually on the line itself. And so when did we do something like that? You guys remember 1.4 maybe or something like that, or what? No functions. 1.3. Yeah, 1.3 is when we did that. So take a look at 1.3 if we need to go back real quickly here. So I'm going to pick 1.4 as my point. My slope is -2. So y minus 4. -2 is my slope, x minus 1. So distribute the -2 into here. Add 4 both ways. And we get ourselves the answer. Anybody know any faster way of doing this right here? Yeah, you recognize this guy. Isn't this guy the y-intercept? Because the x value is 6. Awesome. If that's the case, you can actually just plug it directly into this formula. And you know all the pieces. Now, it's a special case. Special case means you know exactly what you needed out of it. So you got the slope, and you bring down the y-intercept, and you got yourself an answer. That's cool. Cool? What do you guys say?
So I did not do that work. I just figured, I just knew that already. Like, I knew that immediately in my head.
Shush. I'm not sure if we just given this information right here, like, hey, f of 1 is equal to 4, and f of 0 is equal to 6.
What I wrote down was x equals 1, then y equals 4, x equals 0, then y equals 6, and I realized that the whole.
Gotcha.
I mean, you probably
Still-
still did mental math to figure it
Yeah,
out though.
so if
can
you can
just
write
down
down.
your mental math.
I really didn't do anything. I just kind of realized that.
Well, maybe you did it unconsciously.
Yeah.
Now that's kind of tough to bring your unconscious to your conscious. So we're going to work on that, Noah. Okay, cool.
I guess I can.
I don't know.
The next one though was in Boston. 7.
What's 7 do?
It was 3
Oh, with the
divided by
1/2?
3.5 minus 6.4285714286.
Whoa, that's for number 7.
Yeah,
I think that was number 8. Number 7 is just 1/2 and -6
yep,
or -3.
yep.
Yeah.
And my
Okay.
answer was 3x divided by 5, or 3.5 minus 6.4285714286.
We weren't supposed to do number.
Gotcha.
I think I'll get for something.
Yeah, hold
I
on.
couldn't figure out the actual fraction that that was.
Uh-huh.
That's too bad.
Yeah. What'd you guys get for 7 real quick here? 6 7s?
Y equals 676 minus 6.
I got, I did it in like decimals or something.
Okay, yeah. So a few people did in decimals and a few people did. Let's do number 7 real quickly. Number 7, same exact thing here. So we have that. And we have that. So converting it into things we know, this would be 1/2 for the x value, -6 for the y, 4 for the x value, -3 for the y value. And then yes, we do have to do this again. So it's going to be the y values subtracted from each other. In this case, you got a -6, so kind of be careful here with the -6, you got yourself subtracting a -6. And then you got this little fun part, which is 4 minus a -1/2.
It's 3/7.
Okay, so I got myself a 3 here on top, and I got myself common denominators. Here we go. Need a 2 here, which is an 8. And then I got myself a 7/2, which makes a 3/1 over a 7/2. Everybody following still? Cool. And then flip just the bottom one, right? And then you got yourself a slope of 6/7. There you go.
Wait,
So a little bit of work there, boom, 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 to get that in.
okay, well, I got the equation to get, any number is where I want it.
But you probably should still do it in fractions because fractions give you precise answers, whereas decimals are not going to give you that precise answer. I know you had 3/3.5 and then you did that, but should give.
Yeah,
Second.
so the 3.5,
So don't want to mess with the fraction anymore. So I'm going to use this point right here as my point here. So my formula to get an equation of a linear function, there it is. Y minus, a -3. We could have just put +3 there, but that's okay. 6/7 goes here, x minus 4. And the 2-step. Almost sounds like a dance, the 2-step.
It is, yeah.
There it is. So the 2-step is you multiply the slope in, and then you subtract out whatever's on the other side. So hold on, I'm gonna do this real quick here. I'm gonna get common denominators already. It's be negative, everybody okay with 14/7 on this side, equivalent of 2? Yeah, okay. And -38/7, is that okay there?
I got 6x divided by 7 minus 6 and 3/7.
6, if you go, no, you off by 1. It would have been what, 5 3/7.
No, because, you do 1/2, plug 1/2 into it, and it's 3 divided by 7, which is 3/7 minus 6 and 3/7.
Let's see. No matter which point you choose, you absolutely have to be able to get back to the same exact equation,
And, well, that would be.
unless I made a mistake.
How come in the equation you said y plus 2 when it's 3?
That's why, because Noah was correct and Elika just figured out my mistake, and math teacher can do math. This should have been a +3, right?
Yeah.
+3, -3 here, so -21/7. Way better. Negative what, guys?
45.
45/7. And now,
This is correct.
thanks, guys, so much for correcting that. Okay, now you have, Noah, now it is -6 3/7.
Okay, so it is 6/7 x minus 6 and 3/7.
Yep, absolutely. Okay, let's jam. 37 now. 37, sketch the graph of this guy. G of x is the negation of the greatest integer function. Oh man, that sounds fun. Okay, we have to put in some points and see where our closed dot's gonna be and see where our open dot's gonna be, because that's, so let me do the graph over here. And this is a new graph for you guys. I don't think we saw this in Algebra 1, so this is kind of a new thing here. So as we do this, let's see, 1, 2, let's go out maybe like 3. Once you go out 3 units, you kind of know what the shape of that is. Okay, so let's plug in 0 into here. 0, 0, 0 makes 0, and that's a closed dot at 0. Everybody good there? Plugging in a just a little bit away from 0, like 0.1. What do we get from 0.1?
0.
0 still. That's right. Because remember this little interesting thing that we have. Maybe, maybe not. We'll see. I like this little thing because it kind of gives me the scale here. So if I'm at 0.1, just a little bit higher, right? Don't forget the negation over here, right? 0.1. The highest integer inside 0.1?
Is there a way to-
0.
Is there a way to mark instead of the highest integer, the round it, forcing you to round it up?
Yep, there's a lower integer function, higher integer function, there's a lower integer function +1, there's a whole bunch of different ones. We just have this one. Okay, everybody okay with 0 still?
Yeah.
Okay, if we put in a 0.5, so let's change this up, do we still get the same thing?
Yes.
Yeah, okay, so looks like this thing is happening like this. It's a nice interval happening over here. Now let's plug in a 1, let's see what happens. A greatest integer 1, but then we jump down here because of negation front, we go down to -1, right? So the dot out of 1 gets you to -1, that's a closed dot. But notice we get infinitely close to here. So if we put in, let's go backwards real quick. So 0.99, what would you guys get for 0.99? 0. What do we get? Yeah, technically, you can erase that. Okay, so you can get infinitely close to 1, right? But once you hit 1, you have a drop on your hands, right? So open circle. And once you do that, you're pretty much, you set. You can check a few more times, but you know what's happening here. You go like this. You're going to drop down again right at 2. Close dot at 2. And keep on going to 3. And then you got to work backwards as well. So if this is the shape of this greatest integer function, let's go backwards. That means I have an open dot here, interval, close dot here, open dot here, interval, close dot here. Okay, talk to me. Are we still jamming? Okay. See, I'll give you guys like a 90s vibe here. Right? Jamming was like 20 years ago. Yes, we can here. Do that just a second here. Okay, so 39. Okay, can you guys do this one real quickly here as I figure out how to turn on the heater? All yours if you haven't done so already, or if you just gained some new information from 37 that you did not have.
So then 2 minus 2 is 0. Brilliant.
My brother, it was my brother was little insisted that -2 minus 2 was +4.
Otherwise, then you warm up again.
No.
Okay, let's go again. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And let's go with it here. Scale for us 0, 1, 2, just to start us off. So if I plug in a 0 in there, anybody? I know it's Monday. -2. So 0 gets you a closed dot at -2. Plug in a little bit higher than that. So plug in like 0.1. 0.1, still 0, right? Still -2. So here it is. I like this. Okay, so closed dot, interval going this way. As soon as I get to 1, exactly when I get to 1, what I got? Open on, in fact, let's go 0.999. How about that first? 0.999? 0, and then you minus 2 from it, so you're still at -2. So infinitely close to 1, but when you hit 1, you get a 1. 1 minus 2 is -1. Everybody good there?
So in this case, it's always the leading number has to be one.
Uh-huh.
So in this equation, the leading number.
I'm not sure what you mean by leading number here. Once I do this right here.
Furthest number forward on each little line.
Uh-huh. Okay. Boom. And I think I got that one right there. We're good?
And then how would you write down this, like, not this equation, sorry, how would you write down the range of this equation?
Do we have to write down range or domain or
No,
no?
I was curious.
Gotcha.
Is that possible?
Sure. That's cool. Extension question. Here it is. Domain would be from negative infinity to positive infinity. The range. You guys ready for this? This is that's a good question by Noah. This should be a good one. Real quick here. Is the range at -1/2? Do we have a range of -1/2? Yeah, right? The range are actually what? This is -2, this is -1, this is 0, 1, 2, 3. They're just integer values, right? Integer values? Yeah, all integers. All integers are the domain. Or you can say, again, a little bit more, instead of a y, such that y is an integer. Like that. And there's a little symbol that we use for integer. I already forgot. I think it's like this. I think it's like an I with an extra. No. Sorry. No, Z. That's right. The symbol for integers in mathematics is like this right here. It's like a Z like that. Our real numbers is like this. And then we have something called complex numbers, which we'll get into towards the end of class. We'll get something like that. That's kind of cool. These little fun little symbols that we use. No, I'm not sure why the Z is there, but R for real numbers, C for complex numbers, but I'm not sure where Z came from. Okay, could be Zorro. Okay, 45 as well. 45, and we are. It was 45, right? Okay, making sure. This one is a piecewise function, so we can start making graphs. So going back over here, let's see, let's think about this here. So anything that's lower than 0, so any negative numbers, we're going to plug into the top function. And with this one, you kind of just want to, this little bit of mental math, guys. You want to plug in numbers that easily take a square root of. Okay, so 0 would be a good one, but hold on, 0 is going to be only used for here, can't be used over there. Yeah, so let's see.
4. No, sorry. Sorry. 12 would be plus 12.
Hold on. We're working with this guy here. We're working for any negative numbers. We're looking for
Negative 8.
-8 plugged into here would give us a negative number that would not work.
Oh, wait, no, sorry, 2. No.
2.
Yeah, 2. Negative 2.
Ah. Yeah, can't take square root of 2 nicely.
Like negative 16. Basically, what I would. Okay, wait. This is where well, I know, but like it needs to be there. It does actually work. You have, but it's just the same graph as the positive one, just on the negative side. Basically, it's an arch.
It's gonna be an arch, but the way we figured out is this right here. We're gonna plug in.
It goes to 4.
Let me do this right here. We're gonna plug in -4 first, because I know if I plug in a -4 into here, I'm gonna get myself square root of 0, which is Thank you. So let's go 1, 2, 3, 4. So I give myself this guy here. Another number I can plug in to give myself a nice value is -3. I like -3 because 4 minus 3 gives me the square root of 1, which is 1. So therefore, I do have some kind of understanding of the way I'm going to go here. Now, real quick here, because of the 0 is our transition number, we do want to plug in 0 into the top function, just kind of see where we're ending. We good? Not so much as where 0 is happening. We want to see the trajectory of like, hey, this is what's happening when it's like -0.1. We good? -0.0001. So we plug in, we are going to plug into the top function and we get ourselves a 2 out of it, right? So that means, yeah, that means we got this happening here. It is going to go like this because it's a nice curve function. But when we get to 0, we're going to have to put a open dot because it's not hitting that value yet. Okay. So that's for the top function, right? Now let's go to the bottom function. So now let's plug in the 0 because this guy belongs to 0. Hey, this is so cool. Check this out. So plug in a 0 into the bottom function gives us a 2. So hold on, we know that this guy actually is a connected graph. We're good. So now we can fill in this little 0 by saying, okay, yeah, that fills in because of this function here. Okay, give me some more stuff. What's some other numbers we can plug in that will produce nice values? Now for the bottom one. 2, plug in a 2, kind of, sort of. We probably should know this. 3 would work, yeah. So square root of 2, if you guys want to, just real quick here for your own knowledge, it's about 1.4. But Abby says plug in a 3. 3 would work well. 3 plugs in, gets us 4 minus 3, which is just a 1. Square root of 1, which is just 1. So 1, 2, 3, 4. I got myself that guy there.
I have some questions about what's happening with that problem. That's 6 minus 3.
Oh, no, that's 4 minus 3.
You can plug in 0.
Oh, okay.
We have plugged in 0. That was a tradition one, but I think you mean
Plug in
4. Yep.
I misspoke.
No problem. So if you plug in a 4, 4 goes in. This is a 4 minus 4, which is square root of 0, which is 0 right here. And then notice after that, you can't get any functions because it goes negative again, right? So this graph goes like this. It's the top half, almost like a dome. It's a stretched out football dome, I guess. So just the top of it. Kind of sort of like that, maybe a little bit more. This is a little too low. I'm going to put this a little higher.
So with the plan, the y-axis be open circle or closed?
It was open circle initially because we had to use this point here because we want to know what was happening. But because these two numbers were exactly the same, we were able to fill in that circle because the beginning of the second graph produced a closed dot on that. 45 good? Cool. Dun, dun, dun. Okay. 45 after. Okay. So let's jam with the rest of lecture here, and then let's see if we can get to that video or not. We'll see. Let's review just real quickly where we're at, and then we'll jump to. So do you guys remember from the other day? We're at 1.7. Transition of functions, and we have ourselves some shifts that are happening. So anytime you have a shift outside of your, anytime you have a C value, right, that's added to the end of the function, it means it's going up and down. If you have a C value or a constant, that's what the C is for. It just means constant. If you have it inside the function itself, that means it shifts it left or right. It's always the exact opposite what we think should happen, right? So if you're subtracting from the X value, you are going to the right. If you're adding to the X value, you're going to the left. Is that the only one we got? So shifts. Oh yeah, then we have reflections as well. So we got these reflections here. So if you put a negative in front of the function, you reflect it about the X-axis. if you stick a negative to as a multiplier to the x value inside the function, it reflects it about the y-axis. Okay, and let's see, just remind myself what I did here. So we combined the vertical shift and horizontal shift together in one unit. That's cool. We did the same thing over here, and then we were done, huh? And then we said, have a good weekend. Pretty much, that's what happened. Okay. By the way, did you guys have a good weekend? No. Oh, ouch. Not for me. There was no homework for me. Just other stuff.
We have like 2 assignments.
We have history, we have biology.
Oh, good. It's.
Yeah, history, biology,
I need to take my RCA class.
Oh, you know what? No. That would not be good.
I'm just like, I just was talking about this.
Oh, history says.
Oh, I already have the honors.
Yeah.
Oh, yeah.
Okay, let's start the reflections then. So let's go back over here. So if you have a reflection, if you have a negative that's sitting outside the function, you have yourselves an x-axis reflection. If the negative sits inside the function itself, that means you have a y-axis reflection. Good. And then we're going to do compression and stretches. And then after that, we are good to go. We'll put a whole bunch of problems at you. So let's do this one. We're on number 3, I believe. I want to do the outside function first here. So all yours. Can you graph for me the square root of x, which we just did? And then the g function is going to be the negative square root of x. Reflection, and then stretches, okay. All right, let's go for it here. So let me change color here. So this will be f of x. F of x would be the square root of x, which is 0, 0, 1, 1, 4, 2. Here's my square root of x function. And talk to me here. A g function will look like what? What is a g function going to look like? Ah, you guys are still graphing that. Absolutely. Yeah, so notice if you reflect 0, right? Negative 0 is still 0. Right, so the 0 spot's going to be the same. But when you go to 1, the square root of 1 is 1, but then you got this negation on the outside. So at this point, it just jumps to -1. Then it also jumps to -2. So the g function, there it is, just takes the reflection about the x-axis. Okay, good there. We'll get to some difficult ones a little bit, starting out slow. Everybody okay here with this one? Is good. Next one, exercise 4. Same exact function, so we don't get too crazy here. And now I'm going to put the square root of the negation inside the function itself. So kind of think about what's happening with the numbers. Don't just, think about numbers. Kind of plug in a few numbers in your head, see which ones make sense, which ones don't.
Still makes sense for this one.
Cool, okay. So then yeah, I'm waiting as I'm kind of just gauging where people are drawing here. So people are just starting to draw this one here. Go for it. I give you guys a little bit of time.
And then you're gonna have a negative square root, negative x.
maybe. Okay, let's go for it here. So the original f of x function, are we okay with 0, 0, 1, 1, 4, 2? You guys are gonna really know how to do squared functions now. Okay, now the fun begins. 0, 0, does that still work? Yeah, 0, 0 still works, huh? Because 0 plugged in, negation of 0 is still 0, boom. And as I go to positive 1, plug in a positive 1 into here, and it does not work anymore, huh? Bummer. But if I go negative though, how about if I plug in a negative 1? Yeah, negative of a negative 1 is a positive 1. Oh, that's right, cool. Square root of 1 is 1. So actually on this side is what I got the answer now. Interesting. So I don't want to use 2, I want to use 4 because 4 gives me a square. So if I plug in a negative 4 this time, negative of a negative 4, positive 4, square root of 2, square root of 4 is 2. Awesome. So there it is. So this guy reflects it about the y-axis, and it's like a bird from a long range view, right? And an artist's canvas. Except one wing is black and one is red, so I'm not sure what's up with that. There you go. Yes. Impressionism. Yeah. Okay, so I've got a tricky one for you guys. Next one. Let's stick with the square root function still. So I got myself, and tell me if I'm going too fast, okay? G of x is going to be, oh yeah, this is fun. See, even Luke says it's fun. All yours for that one. Think about what's happening. Go back in your notes if you need to here. It's gonna as we put this together. Yeah, 2 is inside the square. Thank you for asking, sir. All right, everything done. Okay. So this is when you do it yourself. Think if you got it right or wrong. We're good. So original function is the square root function 0, 0, 1, 1, 4, 2. Everything's fine and dandy here. And talk to me here. What transformations do we do here? Okay, horizontal shift. And it's left, right? Left 2 units. Reflection. Cool, yeah, reflection about the x-axis. So let's see if this makes sense. We're gonna take the 0, 0. We're gonna shift it back to the left 2 units. So we go from here to here. And then we reflect about the x-axis. If you're already on the x-axis, it just stays, right? Because there's no reflection here. So boom, right there. So how about the 1, 1 here? 1, 1, we're gonna go reflect, we're gonna go back 2 units, and then we're going to flip it across the x-axis. We're going to take the 4, 2, we're gonna go back 2 units, and then we flip it across the x-axis, which is about right here. All right, no, that's 3. A little too far. About right there. Boom. Okay. And here's what I got. All right, quick raise of hands. How many got that before I gave you the answer, not after? Okay, cool. Okay, need a little bit more work with that one or no? What do you guys say? Talk to me. Or no one's talking, it's Monday. Okay. There you go. Okay, so we got that one. So think about, so we got shifts all taken care of, we good? We got reflections all taken care of. And now last one is something called stretches. And we gotta learn these together here. These are called stretches and compressions. This one deserves two different. Okay, stretches and compressions. Let's go. Let's go to Desmos like we did before here. This Come on, let's go faster. Let's see, 10 more minutes left here. Yeah, we're gonna have to go quickly here. So, graphing calculator on our hands. And here's what we got. And this is gonna look kind of weird at first here. Vertically is gonna be easy. Okay, so x squared. Everybody good there? And I'm gonna put it 3x squared. Talk to me. 3 times, so it's going 3 times faster. Does that make sense, guys? It's going up 3 times faster now, as opposed to here. So instead of going out to 1, 1, let's actually zoom in right over here. So notice right here, instead of going up 1 over 1, this is the red line right over here. Now we have over 1, but now we have all the way up to 3. We're good. So we call it a vertical stretch, which means a vertical stretch of 3, which means we're kind of like stretching that red graph, stretching it up 3 times faster. That's kind of what we're looking at. Okay, how does that look like on our little graph? Here it is. So a vertical.
Are you kind of multiplying this slope?
Absolutely. Good way to say it here. And the slope is 3 times faster. So vertical stretch of this new function. And how did we do the old ones here? Let me just check real quickly here. We did f of x, right? Yeah, so f of x. Whoa, that was fast. There it is. We are here. So what we do is we put a constant in front and we just multiply it. Capital C, little c, whatever you like, but we have ourselves a vertical stretch. Now, the only little thing is this. The vertical stretch happens as long as c is greater than 1. Right, that 3 that we just did, right? 3, everything went up 3 times faster. What happened if it was like a 1/2? It was slower, yeah. So instead of saying we go up slower, what we do is we say it's a vertical compression down. We good? So it's compressing the function as opposed to stretching it. So we got vertical compression happening if c is between 0 and 1. Now, if c is 1, then who cares? It stays the same, right? Talk to me. What happens if c is negative? Trivia question. Whoever gets it. What happens if c is negative? What is it called? It starts with an R. It's a reflection, right? If c is negative, it's just a reflection about the x-axis. Okay, and now we got to do the horizontal stuff here too. So horizontal stretch. And it's going to be x. Now this time, it's a multiplier to the x value. Okay, guys, just real quick, let's think about this here. Remember when we did the vertical shifting up and down, right? If it was positive, it went up. If it was negative, it went down, right? For the horizontal stuff, what changed? Yeah, and it went differently, right? So if you added things, right, it went to the left, right? If you subtracted stuff, it went to the same thing here. You have a horizontal stretch. The stretch here happens if the C value is actually small. We'll do one just a bit. Good. Then we have a horizontal, so it's always the opposite of what we think. I took a math class in which it was a, thank you. So I was thinking about the math class. The professor there, he decided to put in a whole bunch of problems, which we think it works this way. It's called mathematical intuition, right? Our knowledge of math says it should work this way on a problem. And he would put these problems on the test even, right? That when you see it, like, no, it does not work that way. It's the exact opposite of what you think it's going to happen. He is not a very nice teacher.
What sort of things is that?
Oh.
Questions on a test that we have gone to and then going, we're gonna go over that now, it's like, why would you do that?
Sorry, no, I'll think of a question like that. But this is part of it right here. This is more like an algebra 2 thing right here. You think it's gonna C values, if C values are big, it expands, right? C values are small, it goes the other way. Okay, we got 5 more minutes here. Let's see if we can get a problem here.
Do we have 5 more minutes? I think we get out now. If our class, you know, no.
Oh, yeah. No, it's like 3 or 5 minutes.
Yeah. Abby's just trying to get out faster.
You don't like math class?
Kind of.
I'm running out of, oh, no, I can do this here.
I just want to know how much more time I have to deal with it. Yeah.
Oh, they're very diligent.
Exercise number 6. Okay, let's see. Let me see of a good one here that we can do. Of x is equal to absolute value. Let's see, absolute value would be good. Absolute value of x, that's our parent function. What we're going to do with this guy is we're going to go like this. That'll be good enough. That'll be good enough for now.
No.
Absolute value. This one goes like this right here. It starts at 0, 0. And the parent function goes with a slope of 1 very nicely up. And this one, it's a V shape always, and it goes like this. There it is. Okay, the G function is going to be, yeah, so notice the X value, anything that's on the X axis is not going to multiply, right? It's still on the X axis. So we got the 0, 0 still here. But this time, instead of going to 1, 1, it's going to go up 3 times faster. So instead of going up 1 over 1, up 1 over, over 1, up 3. So how about this one, and keep on going. So 3 times faster as it's going up.
I love that. Sounds so good. I am so enthusiastic. Thank you for noticing.
Okay, are we good there? 3 times faster on the info. Okay, so let's see, one more problem. Let's put this all together and then let you guys do the homework here. I still like the square root function because it allows us to sort of see a lot of stuff here. Yeah. 2x square root with the negation in front of it here. Okay, we'll finish off with this one and think the rest. On the homework, we will kind of put all these things together, right? You'll put the shifts together with the reflections with that one. At least want to put 2. All right. Let's jam. Original function. 0, 0. 1, 1. 4, 2 is my parent function. 2. And now I have this to deal with. Good. Abby says reflection upon the x-axis. I totally agree.
And it's expand, it's stretched.
Stretched or compressed? Let's see what happens here with the minutes left here. So if I were to plug in a 0 into this function, 0, everything is still the same. Is that right, guys? 0, 0, 0. If I were to plug a 1 into here, once I plug in a 1, if I multiply by 2, I'm already at square root of 2, right? That's not fun.
So 1/2.
So what do I need to plug in order to get a 1 to take the square root of? I got to plug in a 1/2. We're good? So I'm compressing it backwards to compensate for that 2. So a value of 1/2 in here would get me square root of 1 with a negative in front of it here. So it gets me that right there. Are we good? So what do I plug in? Good. 2, yeah. In order to get to 4, right? The square root of 4, I only have to plug in a 2. 2 times 2 is 4. Square root of 4 is 2, and I get a -2, which I'm right here. We're good. See how the black graph on top, it goes out faster, right? And the red graph is going to be compressed back to the y-axis. And so if I need to do 9, which is square root of 9, right? It'll be 4.5. So 4.5, I'm here already. 8 is 16, so I'm already here. So notice that this guy is, even though it's coming out like this, it's really just being compressed back to the y-axis twice as fast. We good? Okay, we'll stop there for today. Thank you guys so much.
That's a very good question.
I think we are, yeah. One